Welcome back to Aurora Tech Channel. Today, I will review the FLSUN V400, a Delta printer that comes with Klipper firmware. Most 3D printers you see on the market run Marlin firmware, which can even run on an 8-bit processor, so it's super cost effective. Even a chip that costs a few dollars or less can run Marlin, but the trade-off is that your 3D printer would be limited by the speed of the processor, whether it's an 8-bit processor like the ATMEGA 2560 that runs at 16 MHz on the Prusa MK3S Plus, or a STM 32-bit processor that you see on many other 3D printers running at 72 MHz to a little over 100 MHz. This is still pretty slow, so the speed and performance of the 3D printer would be limited by the processor, meaning it can only print at around 50 to 60 mm per second, or up to 120 to 150 mm per second at most. To install Klipper on a regular 3D printer, you will need another higher speed processor like a Raspberry Pi 3B and 4 to run Klipper firmware. Then, use the motherboard with the slow processor as an adapter to control the stepper motors. A faster processor can provide more accurate control, resulting in higher print quality and faster print speed. However, as no one can get a Raspberry Pi at a reasonable price due to chip shortage, this discourages many users from adding Klipper to their 3D printers. This FLSUN V400 is one of the few 3D printers on the market that come with Klipper firmware. It claims to be able to print at 400 mm per second, which is really fast. I reviewed their FLSUN Super Racer earlier this year, and it was one of the fastest printers I've reviewed that runs Marlin firmware. It was still able to print at 150 mm per second. It looks like the V400 is a larger version of the Super Racer with a few upgrades. They share some common features like the Delta kinematics, a detachable auto bed leveling sensor, a 32-bit motherboard, and silent stepper drivers. There are also some upgrades, like how it runs Klipper firmware and Linux OS on a 1.6 GHz quad-core A53 processor, a dual-gear direct drive extruder, an all-metal hot end that can print up to 300 degrees Celsius, a PI spring steel print surface, and a 7-inch touchscreen. The hardware looks pretty good to me. I would like to thank FLSUN for sending me this machine to review, and with that, let's get started. We have the base, the top, 3 extrusions with a steel wheel motion system and stepper motors to work as the X, Y, and Z axis, the print head, 3 sets of carbon arms to mount the print head, a 7-inch touchscreen, end caps for the extrusions, and some tools. First, install the X, Y, and Z axis at the base and top. These 3 axes are actually identical, but I just followed the order according to the instructions. We can now put a mount on each axis and connect the print head at the other end. Connect all cables on the print head to the top connectors, following the colors. You will have one final white and blue cable remaining, which is for the filament sensor. Connect it to the filament sensor and fix the entire cover to the top. Then, secure the filament holder, followed by the end caps. For the last one, there is a wire that needs to be run through the extrusion to reach the base. It would be better to do this when you connect the extrusion to the base and top, but since the space inside the extrusion is tight, it isn't easy to push the cables through. I ended up using a thinner USB cable, then using some electrical tape to tape the cables to this USB cable and let it work as fish tape. Now, the cable can reach the bottom and I can connect it to the connector at the base. Next, connect the monitor power, the USB cable, and the auto bed leveling sensor. Remove all the tape on the extrusions, and as I'm in the US, I will switch the voltage of the power supply to 115 volts. We can connect the power and turn on the printer. The 7-inch screen, or should I call it the tablet, is running Klipper. Let's start with Auto Home to make sure all the cables, motors, and sensors are working. The limit switches are at the top, so the print head will go up to the home position. Then, let's do auto bed leveling. It has two items inside the auto bed leveling menu, Calibrate and Bed Mesh. Let's start with Calibrate. It's going to probe 7 points on the bed. After that, we can run Bed Mesh to probe 29 points on the bed. Next, remove the auto bed leveling sensor and move Z to 0 to set the Z offset. Let's preheat the printer and feed in some filament. Let it run through the filament sensor, push down the lever, and let the gears grip the filament. I will use the screen menu to extrude some filament. I will also set up Wi-Fi by selecting the SSID of the network and entering a password. Let's go to the computer and set up this printer's profile in Cura. FLSUN put the profile in the USB drive that came with the printer. You can just copy one folder and a few files to the Cura installation folder to add that profile manually. Then open Cura, select Add Printer, Non-Network Printer, FLSUN, and you will see the V400 profile here. Okay, let's start with the calibration cube. It will only take 12 minutes with the default profile. It's printing at a 0.2mm layer height with a 0.3mm first layer, and it's printing at 210 degrees Celsius, which is 10 degrees higher than normal for the filament to melt faster. There's only a 0.6mm retraction distance and 400mm per second for speed. Of course, you can't print everything at 400mm per second, so the walls will slow down to 120 to 280mm per second, and the first layer will still be 25mm per second to ensure it sticks well to the bed. Everything looks good to me, so I will save this file to my hard drive and open the Klipper web interface. The webcam you see here is plug and play. I grabbed one of my unbranded $10 webcams from Amazon, and it works just fine with Klipper. Select Upload and Print, and it will start the print right away. As the print bed does not move at all, the layers are printed much better than those by a bed slinger. As the printing speed is fast, it took just around 11 minutes to finish this cube. There's a little bit of ghosting on the X and Y. Besides that, I can't see any other issues except the top Z surface was not perfectly flat, resulting in a slightly taller Z height being measured. Up next, I will print a 3D Benchy with the same default profile and the same Voxel PLA Pro filament. There is a bit more stringing than expected. I'm not sure if the high speed caused this or the retraction settings, but I just used the factory profile and it should be fine. I will run the exact same G-code again to print the Benchy with $13 Eryone white PLA and see if it makes any difference. Overall, they do look the same. Good layers, good cooling, good overhanging, but a little bit more stringing than expected. Now, I will try a larger print. This model of the Big Ben by Mini World 3D took a little less than 10 hours to print, even with this V400. If we printed the same model on a regular printer like the CR10 Smart Pro, it would take 40 hours. Let's print this with Eryone bronze PLA filament. The result is awesome. It looks really nice from bottom to top, and even the tiny tip at the top is printed nicely. There's still a bit of stringing around the top part of the model, but overall it looks really beautiful. After that, I will try to print this model of Deadpool with Voxel PLA Pro. It's going to take 5 hours and 37 minutes, but compared to a normal speed printer, which needs 23 hours and 20 minutes, it is still pretty fast. This model was also printed great. The detail on the body looks good, there are no issues on the side, and there are no issues on the back. It is really impressive to get this kind of print quality at this high speed. Next, I will try to print this bearing and see if the accuracy of this printer is good enough to handle the clearance for this bearing. I will use Eryone $13 white PLA. The result is pretty good. I can spin it freely and use a drill to spin it, and it's pretty fun to play with. Then, I will print this set of rugged boxes with Eryone black ABS filament. As you can see, the fillet at the bottom of the box may cause it to warp, but let's just try to print it on this texture PEI spring steel sheet and see how it does. After a few layers, it didn't stick to the bed, and the print head was dragging the print around the bed. So I had to stop the print, clean the bed with 99% isopropyl alcohol, and apply my very reliable $3.25 Elmer's Craft Bond Extra Strength glue. It honestly works better than other glue sticks and special formulas that cost 8 times more. As expected, the print finishes without any problems. This printer is printing ABS at the same speed as PLA without any issues. The bottom sticks perfectly, and there's no sign of warping. I will apply another thin layer of glue to the print area and print the body of the box. It looks awesome and was printed just as well as the lid with 0 warping. I will also print 2 latches for the box. Since this box was designed for using M3x30mm screws, I don't have the exact screws now, but it still fits nicely. This box looks great. Next, I will try to print this laptop holder with PETG. As PETG is not suitable for being printed at a super high speed, I will reduce the speed to 100mm and increase the infill to 50%, as I want this part to be strong and weigh more. This print will take 7 hours and 21 minutes, which still isn't too bad compared to a normal speed printer that will require 23.5 hours. Somehow, the skirt was pulled off by the print head and got into the model, but I just let it print and hoped it would be buried by the infill. The result seems pretty nice. The skirt was buried inside the infill, and I can't even tell it was ever there. I use this to hold my print surfaces, and it works just fine. Since this all-metal hot end can print up to 300 degrees Celsius, I will print a Bose TV speaker mount using nylon carbon fiber. I will set the speed to 100mm per second, and it will take 1 hour and 13 minutes. The result is okay. When the print head travels between these 3 points, the filament drips a bit, but the back looks perfect. After some easy cleanup, it still looks good. As I need 2 of these, I will use the same G-coat to print with polycarbonate carbon fiber. This time, the filament did not drip like nylon carbon fiber, but this area is not very clean. There is an issue with 1 layer here, but besides that, it looks alright. Compared with the PCCF and PA12CF, though they are both quite easy to print, the appearance may not be good as PLA. However, they are more rigid and these two parts are definitely functional. Finally, I will print a set of soft pads for the mount. I will only use 10% infill as I want them to be softer, and I will also reduce the speed to 50 mm per second as TPU can't be printed at such a high speed, so the print time will be almost the same as a normal printer, which will take around 1 hour and 14 minutes. The front as well as the back are printed nicely, and they fit perfectly on the mount. Okay, let's talk about the pros and cons of this printer, starting with the pros. 1. The Klipper firmware that runs on a quad-core processor is definitely above the level of the Marlin firmware that runs on an 8-bit ATMEGA or 32-bit STM processor. The print speed is really fast, and it can print at 400 mm per second with 8,000 mm per second squared acceleration. It may not be the fastest printer in the market, but printing a 3D Benchy in 30 minutes with this quality is still pretty good. It prints larger models up to 4 to 5 times faster than a regular 3D printer, as larger models give more distance for the print head to accelerate, but it still prints 3 times faster for smaller models. It prints PLA and ABS at up to 400 mm per second. It prints PETG, nylon carbon fiber, and polycarbonate at 100 mm per second and TPU at 50 mm per second. It is much faster than a regular 3D printer, except for when printing TPU. 2. The dual gear direct drive extruder and the extra large volcano style heated block work very well. This setup melts filament fast, and I didn't see any signs of under extrusion even when printing at 400 mm per second. 3. The Klipper Wi-Fi feature is much better than any printer that uses Marlin. The upload speed is not limited by the ESP Wi-Fi module and the serial port, which takes a few minutes to upload large G-code files. The web interface is also really nice. It supports a webcam, file management, and you can just change the printer configuration without recompiling the firmware. 4. The 7-inch touchscreen, or should I call it a 7-inch tablet, is very responsive and the screen is sharp. The Klipper screen is beautiful, and the menu structure and button locations are all reasonable and easy to use. Overall, it seems FLSUN has integrated Klipper firmware with this V400 pretty well. Now for the cons. 1. The motion system on this $850 V400, unlike the $500 Super Racer's linear rails, uses steel wheels. I didn't see the steel wheels not working as well as the linear rails or linear rods during the tests, but personally, I would prefer linear rails as it just feels more premium. 2. Some small details like the drawer on the base and the screen mount are missing. For the Super Racer, I put the bed leveling sensor in the drawer when it wasn't in use, but I don't have a place to store it on this V400. Using a stand for the 7-inch screen also isn't a very good idea. It occupies extra space on your table, and it would be better to make a mount and have the screen mounted on the printer frame. 3. This printer strings a bit more compared to my other printers. The default retraction distance of the slicer profile is 0.6 mm. I tried increasing it to 1 or 1.5 mm, but the difference isn't that obvious. I believe it could definitely be improved by tweaking the printer profile, so I suggest that FLSUN should do more of that and release a better print profile. I would also like to see a benchmark G-code file, like a 20-minute 3D Benchy coming with the machine instead of some other random models. The benchmark G-code file should also be optimized to work with the sample filament that came with the printer, so the user can experience what this machine is capable of right out of the box. 4. The diameter of the print bed is 300 mm, and its footprint is almost like that of an Ender 3. However, the required height for a Delta printer is much more than a bed slinger. The printer itself is 37 inches tall, and with the height of the filament roll, it is almost 45 inches tall, which is around 1,100 millimeters, while its maximum Z height is only 410 millimeters. 5. The time zone is set to the other side of the world. The Klipper screen has nowhere to change the time or time zone, but it's a Debian Linux OS, so I should be able to log in with PuTTY to change the system time zone. However, I can't find any hints for the root password anywhere, so the time shown on the screen is never correct for me. In conclusion, this is a very solid printer with Klipper pre-installed. It runs smoothly and will definitely give you a different experience compared to all other printers running Marlin. You can expect it to print around 3 to 5 times faster depending on the size of your print. The print quality is still pretty nice when printing at a high speed. So, if you are looking for a larger size 3D printer that prints fast, has Wi-Fi, a super nice web interface, and a direct drive extruder with an all-metal hot end that allows you to print a broad range of filament up to 300 degrees Celsius, you should definitely take a look at this FLSUN V400. I put the link under the description. That's it for this video. If you liked this video, please hit the like and subscribe button and click the notification bell to receive new video updates. I will see you next time.